to this second session. Kubernetes and security can be true if applied correctly. So a lot of the content I'm going to be talking about today is based upon some of my personal experiences in different projects that we're working on. So large customers and small customers. So it's going to be a wide range of different topics that I'm going to go through and cover. So I'm going to also talk about some attack vectors and some of the security mechanisms, and also a little bit about some attacks that have actually experienced customers, and what was the attack vector that was used to actually gain access to the clusters. So as part of this presentation, I also made a catchphrase, even though it sounds a lot better in my head, because when we're moving towards Kubernetes and like a cloud-native platform, it's about giving developers much easier access to be able to implement changes more rapidly, right? So it's having high velocity. So I came up with the catchphrase, which is now termed maintaining high velocity while still wearing a seatbelt. Hopefully it'll catch on. Sounds a lot better in my head than it actually did on writing, but it's making sure that we have security implemented in every step of the way, right? Making sure that we can still do those rapid changes without filling out Excel sheets and change requests when it comes to opening firewall rules, etc. So that's going to be the essence of the talk for the next 45 minutes. So who am I? My name is Marius. I work as a cloud evangelist at Steria. So I'm a 5-year-old with ADHD symptoms, so moving around and finding new topics to talk about and work on. Even though the last 6 months has been a lot on GPT and language models, I always fall back to security. I also have some other hobbies outside of work, which often requires me to sit in front of the computer anyways. Drives my wife crazy, but that's we don't share the same interests there. But I also work on another security user group. I have a podcast together with a good friend of mine. I do some blog writing. I also recently wrote a book on ransomware protection, so more on the traditional infrastructure side. And I also, outside of all the technology-related stuff, and as I said, I needed to add some pet pictures here as well, so I also have 3 dogs. And no, I'm not colorblind. This is by design. I haven't decided yet on which color I want to focus on, but at least I have 3 of them, so they are my closest colleagues working from home. As with all presentations in 2023, we need to have a ChatGPT quote. I actually found this quite useful because I said, okay, what's the biggest challenge when it comes to securing Kubernetes? And of course, sometimes it hallucinates, but this, in this sense here, we can see that it's actually came up with a good answer. Because Kubernetes can be small, can be large, and it's dynamic by default. We can add add-ons, extensions, we can add new capabilities, we can add new networking functionality, new storage functionality. It also means that we need to think differently when it comes to actually implementing security into this new stack. And of course, it's a big ecosystem of tools available that we can choose from when it comes to implementing security on those different aspects, which I'll cover a little bit afterwards. We also see that the threat landscape is changing. This is a quote from the latest National Security Authority Risk Report, which came out early this year, where we see that there's a lot more cyber attacks targeting now Norwegian organizations, a lot more than before. And then we have another scary graph, which is going in the wrong direction, and that's the amount of vulnerabilities that we've been seeing, which also increases yearly. Now, so far, 2023, we see that the number will be even higher than last year. Of course, vulnerabilities can be across multiple different products and vendors, but it's something that we need to have into consideration when we're looking into detecting vulnerabilities into our application stack. So when we look at the attack vectors from a Kubernetes perspective, we have like two main categories, if we will. We have the developers, which of course now has a lot of access to different tools. They have access to the cluster, perhaps either directly through the developer environment, or they have through some form of API or some tooling, or from the CI/CD pipeline. And of course, we have seen now more targeted attacks against developers, being able to steal access tokens or personal access tokens that are stored locally, or any type of credential that is stored locally. So we have now new malware loaders directly targeting and trying to get out information from local Visual Studio Code applications and so on. And then we have well, more targeting the IT or the infrastructure layer where the platform is running. Of course, we've seen a large increase in DDoS attacks here in Norway. Microsoft was one of the victims a couple of weeks ago. And we have, of course, services that might be exposed publicly, but we don't have any security mechanisms in front of those, or we have services that are exposed but has a large list of vulnerabilities that can be exploited by those who want to exploit it. So, of course, we need to take all this into consideration when we're actually looking into how can we secure this entire stack. And then we, of course, move more into the Kubernetes environment ecosystem. Then we have a bunch of new different risks that we need to consider. I'm not going to go into all of these into detail, but Microsoft has actually made something they call the threat matrix for Kubernetes, which goes into all of the different components in the Kubernetes platform and goes into different countermeasures that you can do to actually mitigate risk for allowing no one to actually abuse those misconfigurations. Of course, there are some aspects here I'm going to talk about following. One of them is specifically like container escape, and that's of course that you have some form of vulnerability in the container which someone is able to exploit and then gain access to the underlying host which the container is running on. And of course, if you have a pretty large environment, you have multiple services running on a specific node, then they can be able to access the secrets, the storage, the data, make alterations to the service. Even though we haven't seen a lot of vulnerabilities actually being able to gain that type of access, we see new security products coming that are actually trying to mitigate that risk. And then we, of course, have identity, much bigger issue than before. Of course, it's not just about getting access to tokens. We've seen new attacks targeting multi-factor authentication mechanisms, such as when Uber was attacked last fall, if I remember correctly. They actually gained access to an employee's user account, and they triggered something called MFA fatigue attack. So they sent this employee numerous authentication attempts on their phone while they were sleeping. And of course, when you wake up and you see a lot of notifications, just accept, go back to sleep. So they actually managed to gain access to Uber's internal IT systems just by using that type of simple identity-based attacks. So we need to rethink this as well. And of course, we see also that there's so many vulnerabilities, a lot of the base container images that we use running. And of course, there are a lot of different tools that we can use to mitigate that risk as well, to be able to find, detect, and perhaps mitigate those vulnerabilities on applications before we actually deploy them to production. I want to start off with a scenario, because it's not just about securing Kubernetes, it's also the ecosystem around it. How does developers gain access, or how do developers gain access to the platform? How they're able to use the underlying components around it. This was from one of the customers that I was working on for a couple of years ago, where they had a Kubernetes cluster running in Azure. And of course, they had some internal deployment environments, so they were running OpenShift locally. They were using GitHub to be able to write the source code, and also using GitHub Actions to actually automatically deploy. But the main problem here was that there was no connection between the user accounts. So the developers that were onboarded to this project, they had one user account to gain access to Azure. They had one user account to gain access to the internal systems of running an OpenShift. And they had no organizational structure in GitHub, which also meant they had a third user account there as well. So there was no link between when an employee was starting or when an employee was leaving in the company. That meant that within their GitHub structure, they had a lot of developers that still had access many months after they actually left the project, which could still be able to read and write to the repositories that were stored there. So not the right way to do this when it comes to actually building those types of environments. So try to focus on building up with a single identity structure that is used across different cloud environments and also where the source code is stored. So I want to start off with one example attack that I encountered. This is probably about 8 months ago. So this customer was spinning up a Kubernetes cluster in cloud, so running it in Azure. So spent a lot of time trying to make sure that this cluster was well, they used the phrase bulletproof. That was the phrase they used. So they spent a lot of time making sure that, okay, we have firewall rules in place and we have single identity. what they didn't expect, and what happened was they were using Kubernetes to do a lot of machine learning workflows. They started up something called Kubeflow. Kubeflow is a simple service that you can use to actually run TensorFlow jobs on top of GPU-based workloads. So what happens by default if you run Kubeflow directly, so just using help chart, installing Kubeflow, it will automatically spin up a public load balancer with a web UI dashboard without any type of authentication required. So what happened? Someone found that dashboard, gained access to it, and started to do Bitcoin mining. So it wasn't directly, so it wasn't dangerous, it wasn't critical, even though it took some time. It took a couple of weeks before we were able to figure this out, because for some reason they saw that, CPU is 100% all the time. That's weird. Again, this is just an example showcasing that you can spend a lot of time locking down Kubernetes clusters. But what happened here is that by default, when you set up the service, it will set up a public load balancer with its own IP outside of the cluster. That is also something that can be changed by default in most cloud providers. Second one, compromised GitHub pipeline. This is also something that we see a little bit more and more of. This is something that happened about time flies, 8-9 months ago. So some developer in an organization got his access token stolen from GitHub. And this access token, of course, had way too much access into the GitHub repository. Now we have, of course, much more fine-grained access tokens that we can apply for GitHub, but it was using the old access tokens. So someone gained access to the access token and used that to actually update the GitHub workflow. And then what they actually did, they modified the workflow. So it collected all the environment variables as part of the workflow and so they contain credentials, contain storage keys, storage account information, which then was sent to a DigitalOcean IP address. That was what we saw from the logs. And so this is throughout the timeline here is throughout a weekend. So they used that information, so the keys, and accessed storage accounts running in Azure, because that was information collected from the environment variables. And then they also tried to log into the Azure portal using those credentials as well. So here we needed to rethink the way that they actually were using secrets and identities in the GitHub workflow. So we also saw eventually that they were able to collect some data from the storage accounts, even though that wasn't sensitive. This was a test environment. So after this, we started using fine-grained tokens. We also made some changes in terms of the workflow and how they do authenticate to the Azure environment. So let's go through the different countermeasures. And of course, some of these scenarios and features I'm going to be talking about, you need to think about, okay, do I need to use this feature? Some organizations will, of course, have very strict security policies, while some doesn't need to have all of them, because it's a lot of per use case scenarios, some of them. Of course, you can't go all the way, making sure that no one gets in. This is always my mindset when I come into a customer organization, making sure that the cluster or the Kubernetes environment cannot be used at all. But in all seriousness, one thing, so let's start with the end user or the developer in this sense, right? How do they gain access to the environment? Of course, traditionally, a lot of developers have gained their own laptop or machine. They have a VPN client and are able to communicate with internal systems, or they're able to use GitHub directly. One of the things that I'm working a lot on with customers now is applying a zero trust-based approach when it comes to giving developers access to the environment and also where the source code is stored. So, of course, zero trust is a set of design principles. So we need to have some form of technology underneath to actually do this in practice. Now, of course, there are some, let's say, different tools and flavors and options that you can choose from, depending on which vendor you work closest with. One approach is, of course, say that, okay, we want to use the Microsoft-based approach to actually provide zero trust-based access. What that means is that when someone's trying to get access, it checks the health on the user device, making sure there's no malicious or any suspicious activity going on, and also makes sure that the user is who they say they are and they're coming from a trustworthy location. And it's also constantly monitoring what's actually going on as part of the session. Now, Microsoft, they have a bunch of different tools that you can use to actually gain access. Of course, for Kubernetes clusters. If you need to gain access to the Kube API, they have something called Azure Arc Cluster Connect, which can be run on any type of Kubernetes platform, regardless of where it's running. It's a bit slow, to be honest, so it takes a lot of time. You add a lot of latency on top, so you don't have the same responsiveness. I tend to use Cloudflare. They have a free option, which we tend to use, and it's just spinning up a Docker container running on the cluster, which can then also be directly connected to the cluster, so gain directly access to the Kube API. But again, there's a lot of different vendors in this space to provide this type of zero trust-based access to cluster environment. And then, of course, need to make sure that we have enough focus on the workbench, or where the developers actually do their magic. Of course, there are different ways to for our developers actually do development. Of course, the standard option is using Visual Studio Code. You have a local application running on the machine. We have some environments where we need to provide a virtual desktop because of might have specific workloads or specific security requirements. But we also see more and more now using such as GitHub code spaces, which is now part of the public GitHub structure. So what you actually do is you spin up a virtual non-persistent container, which is available through the web UI. So you have a Visual Studio running as part of the web UI instead. Of course, you have a lot of security mechanisms there. You can make sure that the network is connected directly into your internal network. You have options to define what kind of extensions should be installed by default. First, the advantage is that this is running as part of a web browser, not directly locally on your machine. So it's kind of hard to harvest credentials as long as it's running in a web browser. So you have GitHub code spaces. You have Gitpod, which is an alternative. I haven't tried it yet, but provides much of the same possibilities as GitHub code spaces. And then, of course, the main feature advantage I see with Visual Studio Code is the ability to add extensions. So many extensions that can make it easier to actually do development and also integrate directly. Of course, the extension marketplace can be a dangerous place because there's a lot of malicious extensions being published. So if you look on the right side here, there's two different extensions that have the same name, but one of them is malicious and actually is used to harvest credentials, while the other is the official one. Of course, there's also a lot of extensions that become quite useful for actually doing security analysis, actually checking the source code before actually checking it in. A lot of them are free. Some of them require some integration with some cloud providers, such as Cheekov from Palo Alto, which can do static code analysis before you check the source code in. And also, let's say you're doing Terraform-based code and you have TFSec, Trivi from Aqua Security. So a lot of different free tools here that we can use to actually check the code before we start checking it in. And then for GitHub, this also applies for regardless of which what source code provider you're using. And also back to the example that I mentioned, making sure that you have one single identity across the different services that you have. So GitHub supports scheme-based provisioning, meaning that let's say that you have Google Identity or Active Directory or Azure Active Directory, you can automatically provision user accounts into GitHub directly. So that also means that if an employee leaves the company, that user access will also be deprovisioned using the scheme mechanism. And you also have single sign-on mechanisms, right? Because even though I have separate, I have the same account, but it's stored into two different catalogs, I want to make sure that I have single sign-on. So GitHub supports SAML and OAuth-based authentication, easily integrated with Azure Active Directory and Google Identity as well. You also have the ability to use self-hosted runners, which means that you can have a virtual machine that is running those GitHub workflows that you set up. And of course, having self-hosted has the advantage that you can control the traffic flow. You can also control which endpoints is allowed to communicate with instead of using the public hosted workers that GitHub has. And that's one of the attack examples that I mentioned. They used a public runner, so they had no traffic inspection on the traffic or no way to manage the traffic whatsoever. GitHub also has a feature called Advanced Security, which is a paid option on top of the existing license, which also includes some security mechanisms such as secret scanning, code scanning, dependency review. So it looks after, okay, you're using this base package and you have a lot of third-party dependencies that you need to have, which might have vulnerabilities. So that's something, a lot of information that you get directly into GitHub as long as you have advanced security. And also look into using defined grade personal access tokens instead of the old ones, because you have much more control now of what those access tokens can be used with. So now we've set up the developer workspace, we've set up the cluster maybe. Now we need to look into how we give access to the cluster. Of course, by default, you can use a token, you can use a certificate. Of course, if you deploy, let's say Kubernetes in cloud, you have a built-in integration with like Azure Active Directory, with Google, with Amazon. There's also a lot of options that you can use to integrate this with other identity providers. So we have, for instance, Pinniped, which is from VMware. You have Dex, but you can also integrate with other third-party providers. And then you, of course, have also role-based access control, which is YAML-based configuration to define which user should have access either on a cluster level or on a namespace level. Now, it's not always easy to understand, see directly who has access into the cluster. I like to have things a little bit visually when it comes to role-based access control. So there's a tool here which I mentioned, SigUp.io Permission Manager, which provides much more visually to see, okay, what kind of access does this specific user actually have on the cluster. And then we have private clusters. I actually did a check earlier today on the train ride down here to actually see how many public clusters do we have in Norway. So Showdown is really helpful there. And what public clusters means is that the Kube API is publicly available on the internet. No restrictions when it comes to authorization on IP address level. So in Norway, we have 233 public clusters, mostly in Oslo. So we have some work to do here. Of course, it's not directly a security risk, of course. But of course, if someone manages to gain access to a token or a certificate that can give access to the Kubernetes cluster, they can do whatever they want. So unless we have some specific, very good role-based access control in place. But as long as the cluster is publicly available, I doubt that they've actually done that work as well. And we have also had some vulnerabilities on the Kube API, which has allowed unauthenticated access directly to the cluster. But of course, going from a public to private cluster, let's say from a cloud provider perspective, often you need to do a reinstallation or a redeployment of the cluster to actually get this functionality up and running. As long as you have deployed this using Terraform or some form of infrastructure as code, it doesn't take too long unless you have a lot of static configuration. So once the cluster is up and running privately, of course, then we might like to do some changes, inspection, or see how well this cluster is configured. There are also some tools here that we can use to actually see how good it's configured according to certain standards. We have, for instance, Kubebench or Kubespace, Kubescape. I always forget that pronunciation. So Kubebench looks at a cluster according to the SIS framework. We can go in and see, so let's say you're running a cluster in Azure, running OpenShift on-prem, so it adapts according to where it's located in the cluster. And then can see, okay, here are some configuration options that you can make sure or change to make sure that your cluster is even more secure than it was before. So you can run this interactively just using the CLI tool, or you can run it directly as part of a workflow as well. Or if you're using the Lens or OpenLens cluster manager, you also have an extension there that can use as well. And then we have upgrading and patching, not everybody's favorite topic. But when you look at the life cycle of a cluster, because it's been so many environments now where we have customers running older versions. And the problem is when you're running an older version, specifically on the cloud, you don't have the support from the cloud provider. You're missing out on functionality, and actually doing the upgrade sequence makes it a little bit more difficult as well. So you need to understand that running a secure platform also means that you need to be up to date on those versions that are being released. And most cloud providers, they have 1-year support on the specific version that you have. So this is a small table that I copied from Microsoft website, just showing those versions that Microsoft support now up until next year. Of course, if you want to fully automate the installation process, because let's say that you're running Kubernetes in cloud, you have patches being installed directly, automatically on the worker nodes, but it's not automating or orchestrating the restart of those worker nodes. So I tend to use like QRED, Kubernetes reboot daemon to actually check, okay, is there a restart required? Then it will schedule a restart of that worker node by clearing out all the pods and moving those to other worker nodes in the cluster. Then we have backup, also not the favorite topic. But for some cases, you might have persistent data running inside the cluster. Let's say you have a database workload. Now, you have a lot of different options as well when it comes to actually doing backup of persistent data running in Kubernetes. You have Valero, which is open source, available from, it's maintained by VMware now. And the fun fact is that Microsoft, they also built a new AKS backup feature, which is actually Valero under the hood, but just added some fancy UI mechanisms on top. Or you have the more commercial options from Kasten, which is Veeam, or you have Portworx backup, which has, of course, a little bit more functionality when it comes to disaster recovery mechanisms. Let's say you have multi-clusters and you have spread across different regions, then you might need those different tools. Another interesting tool, which is not directly related to security, but there's a tool called Kubester, which can be used to actually benchmark and test CSI drivers or CSI storage options that are available in the cluster. So I tend to use that when we're doing some benchmark testing or stress testing on new services that need to be deployed. And then we have pod security admission, which I think was introduced in version 1.24. Now it's about, so containers, they run in an isolated space. So it's from isolation between what's running in the service and what kind of communication is allowed to talk down to the underlying worker node or the kernel. Now, pod security admission allows us to define different isolation layers, or which level of isolation that we want to have. So we can run on 3 different levels. Either restricted, means it's pretty locked down in terms of what kind of operations that it can do. We can have privilege, which we don't have any limitations whatsoever. Or we have baseline, which is something in between. Now, pod security admissions, we can define which of these isolation levels should apply on a namespace level. So we can say that, okay, we need to enforce restricted pod security admission on that specific namespace. So if a developer or someone is trying to deploy a service which violates those policies, they will not be able to deploy the pod there or the service there. We can, of course, enforce it, or we can use audit, which will only create an entry in the audit log for Kubernetes saying that, okay, we have some services now that are violating this pod security admission on that namespace. Warning will only give give the developer or the workflow feedback from the Kube API when it's trying to actually do the deployment. Now, of course, we have different layers of isolation that we can apply. So pod security admission is one of them. We're also seeing now new features being introduced. We have something called gvisor, which is, I think it's out of Google, but they're trying to emulate kernel calls directly. So it's sitting in between the container and the underlying host. So if the container needs to do some kernel calls, it will go through the gvisor API. We also have something called Kata containers, which I see some of the cloud providers are focusing on now. So instead of setting up its own container, it's actually setting up a lightweight virtual machine and then running the containers inside there. So of course, more fully isolated compared to traditional containers. And the last part is something called confidential computing, which is now also being introduced in different cloud providers. And it's more about encrypting all the processing inside the containers, because by default, you can have encryption on the communication, you will have encryption on data that's stored at rest, and confidential computing actually encrypts what's going on inside the actual container. So in theory, it means that not even the cloud provider can actually see what's going on inside the container. But again, that's all about what kind of use cases that you have. Sometimes, question? Yes. Yes. So, yes. So how can you monitor pod that's running encrypted? That's the question. Yeah. So the confidential computing, what it actually does is using functionality from the CPU vendor underneath. So it's encrypted from the hypervisor level. So I can still see what's going on if I have access to the container. But confidential computing helps from the service provider level because they won't be able to see what's going on in the virtual machine from the hypervisor layer. So let's say that I have a hypervisor and I'm running a virtual machine. I can do a memory dump of that machine and be able to inspect what's going on. But if I use that type of functionality and have confidential computing, then all the everything inside the memory dump will be encrypted. So as a consumer or using that feature, I'll still be able to see what's going on. And of course, that's a good transition to actually seeing what's going on inside the containers. Because sometimes we also need to make sure that we see what's actually going on inside the containers. Let's say that we have some form of service that needs to have much more audited response, seeing what's going on. There's a lot of different tools there as well. I also see that I haven't actually translated that to English. But what these tools do, they actually use eBPF to actually have small sandbox applications to actually inspect what's actually going on. So we have something called Falco that can actually see what's going on inside the container, what kind of API calls it's doing, what kind of reads and writes to the file system, what kind of network communication flow it's going. We also have a Tetragon, which is from Cilium. They also have a CLI-based tool, which can also be able to inspect and see what's going on. Now, we also have one of those tools, KubeArmor. They can also see what's going on and then automatically create network policies based upon the traffic that's being flowing through the containers to different services, while the others are more looking into what's going on, being able to audit the traffic. And then we have container registry, right? Well, now we've set up the cluster, we've employed some different security mechanisms, which is running privately, and then we're now starting to deploy applications. And of course, we need to start with some base images in some cases where we're using a Python library. Of course, a lot of the custom a lot of the standard images that are publicly available, they have a really large footprint, such as the Python image, which is 800 megabytes large, and it has a lot of vulnerabilities by default. But a lot of these default images also have slim versions, which is smaller footprint, only some specific modules or libraries, and also has a lot lower vulnerabilities, and also often stated as part of the Docker Hub repository when you go in and see on the different container images that are available there. Of course, you also have the option to set up container registry services publicly or privately, so only being able to check in images as long as it's coming from a trusted source, a trusted network location. And you can also include, there are a lot of security services that can scan for vulnerabilities before the image is actually published into the container registry. And then we have secrets, passwords, certificates, tokens. Of course, you can of course store secrets in Kubernetes. They are by default not encrypted. They're stored in the etcd database. You can of course set up something called encryption at rest. So it's encrypted physically, but of course, as long as you have access to the API, you can actually read those secrets. And then you have also some different options when it comes to, okay, should I store these secrets outside of Kubernetes, and what options do we have? So we have something called the external Kubernetes secret operator, which supports the different cloud providers, third-party tools, or we can use something called the secret CSI driver, which supports the cloud providers and HashiCorp Vault at the moment. So that means that, let's say that we use the secret CSI driver and someone is deploying a service. When that service starts and the pod is initialized, it will load the vault as a volume and then import the secrets from that vault. So it's not so much configuration to actually get this up and running. Then we have workload identity, which also was mentioned in the previous session. And this is about not actually using secrets at all. You have some short-lived keys that are exchanged between different services. The workload identity is one of those. So it uses the OpenID Connect specification to do authentication from Kubernetes to It can either be done directly to get a workflow, or it can be run directly to the cloud providers, meaning that pod running on a cluster is able to authenticate to another PaaS service running in the cloud provider. So, of course, at the moment, this is supported by Microsoft and Google. You also have an open source initiative, which is called Spife and Strive, if I remember correctly, which uses certificates to actually make this type of authentication. That means you can use this type of functionality on any type of cloud provider or on-premises platform that you might have. And then moving on into the network space, of course, there's a lot of acronyms being tossed around when it comes to Kubernetes. Of course, the most important one is the CNI, so the Container Network Interface, so that actually being able to integrate Kubernetes with the underlying network fabric that you're running on, regardless if it's cloud or on-prem. Of course, there are a lot of different options to choose from here as well when it comes to actually using specific CNI. Now, of course, again, network in Kubernetes, open by default. Not something that security people like to hear, but that's the case at the moment. And if you're going to a public cloud provider, you have different CNIs you can choose from directly. So if you're going to Azure, you have Azure CNI. If you're using Google, you have Google CNI. But you also have third-party options that you can use on top as well. So such as Cilium now has its own CNI, which you can use on Azure. For Google Cloud, so the DataPath version 2 is running on Cilium. So you have like a lot of different options that you can use when it comes to using CNI as well. And then you need to also define firewall rules, so access rules, what services can actually communicate with other services on the same cluster. And again, here we're stuck with using YAML configuration files. We can use tags to define which service should be able to talk to different services. And again, there's a lot of different tools here that we use as well to actually visualize the access rules instead of trying to read everything in YAML context. It makes my eyes sore if I'm looking at a longer period of time. Of course, network policies, they operate on layer 3 or layer 4, right? So it's IP port protocol. But what if we need to do this on a higher level? What if we need to actually look what's going on inside the application context? And this is, of course, where service mesh comes into play. Who here is actually using service mesh? Please raise your hand. Okay, so about half of the people here. So what service mesh does, it's a way to actually, let's say, move out network functionality outside of the container. So instead of everyone looking into how they solve authentication or certificates inside the service, this can be a property delivered directly from the platform. And also being able to provide load balancing mechanisms, provide insight in the network layer as well. So of course, service mesh is a principle, or not a principle, but a set of guidelines on what kind of functionality it should provide. And then we have, of course, a lot of different options here as well. And there's also different architectures that you can use depending on which kind of vendor that you use. Of course, you have like 3 main service mesh options that are available today that most companies use. You have Istio, you have Cilium, and you have Linkerd. So of course there are some differences between these three different vendors. So Cilium uses eBPF underneath, which means it can inject traffic directly into the networking stack on the inside the kernel. Istio uses just making changes to IP tables, and also uses something called a sidecar architecture. So for each pod that you deploy, it's going to get its own sidecar container, which is going to intercept and handle all the communication flow. Now, this is actually something that's going to change because service mesh, the architecture now is going to be changing into something called ambient mesh. So that means that the sidecar component is going to go away. But that's going to, I've seen some early drafts or early versions of that new architecture, but I haven't seen too much on it yet. But using service mesh provides much more insight into layer 7. And it also provides a way to do secure authentication between different services inside your cluster. As I said, there's a lot of different options. Istio Linkerd is one of them, depending on, again, on what kind of use case that you have. Because let's say, I run service mesh on Kubernetes, but then I need to communicate with a lot of virtual machines outside the cluster, and I might need to be able to extend service mesh into those as well. So then we have, for instance, HashiCorp Console, which provides service mesh capabilities from Kubernetes to Kubernetes and also from Kubernetes to virtual machines. There's a lot of different options here. One thing that I discovered on the train ride here is that Open Service Mesh now, which was an initiative actually, I think it was started by Microsoft, but it's actually now end of maintenance. So they're focusing their initiatives into Istio instead. Security monitoring from Kubernetes. So by default, we can set up, monitor all the changes that are going through the Kube API. So if someone's making a change to Kubernetes or deploying a service, we can actually audit that process. So of course, we have different levels of auditing levels that we can define. So by default, we don't actually audit anything. We can define that, okay, we need to monitor all the requests that are coming in, but also monitor all the changes that are being applied. And in most cases, we tend to export all those audit logs to CM tools such as Splunk or Elk or Loki or Microsoft Sentinel. So they tend to have a pre-configuration that you can apply to actually collect all those logs. And of course, it can be quite useful when something is not working with the cluster, and then you figure out, okay, who actually made a change earlier today, which will impact or which impacted the cluster. We also have a lot of, let's say, commercial products that we can use on top of Kubernetes. So we have some tools that are focusing more on the coding side of things. So looking at code analysis, making sure dependencies are okay, so we don't have any large or high impact vulnerabilities as part of the code or the image. Or we have more tools that are not just looking into the source code, but also looking into the cluster and see, okay, are there any misconfigurations on network policy side or any misconfigurations on the way that the cluster is configured? So it's all depending on what kind of functionality that you actually need. Of course, the price tag can be quite high in these different products. So the final slide for me, of course, I've talked about a lot of different options and different security mechanisms, but of course, I always look into starting with the simplest things that you can start with, such as making sure that you have private cluster running in cloud, making sure that you have control of user accounts and who's able to access to log into the cluster, making sure that you have some network policies in place to actually not allow all traffic by default inside the cluster, and also making sure that you have control of the version that you're running so you're up to date and get support from the vendor that you're using. But again, a lot of these is also depending on what kind of use case and which organization that you're working for. With that, I think I'm going to wrap up. This is my final slide. So thank you so much for listening, and enjoy the next talk on sustainability.